Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, in the previous class, we have discussed about motion, rest, distance, displacement, speed, velocity, and acceleration. And we have also known about which quantities can be referred or regarded as vector quantity and which quantities can be regarded as scalar quantity. Okay, so with that, let us carry on to our next part of the chapter, in which we will be studying about the graphical representation of displacement, velocity or acceleration. Okay, so just take out your pen and copy and make a heading. Okay, so graphical representation of linear motion. We have been studying about linear motion. So basically this part of the chapter is related to graphical representation of linear motion. Okay. Now, when you talk of graph, you must be wondering about x-axis, y-axis. Okay, so definitely we will be talking about those axes, and we will be also talking of which thing is represented by which axis. Now, there are actually three graphs that we are going to discuss. There can be a displacement time graph, there can be a velocity time graph, or there can be an acceleration time graph. So if I consider the types of graph, so there are three types. First one is the displacement time graph. Okay, second one is velocity time graph. Okay, and third is acceleration time graph. Okay, acceleration time graph. So these are the three kind of graphs that we are going to discuss: displacement time graph, velocity time graph, and acceleration time graph. Now remember, in all these three kinds of graphs, we are always going to take time as the x-axis. That is, we are going to plot time on the x-axis. And if you are considering displacement time graph, so displacement will be on the y-axis. If you are considering velocity time graph, velocity will be on the y-axis. And if you are considering acceleration time graph, acceleration will be on the y-axis. So basically, in all three types of graphs, remember one thing, that we always take time as on the x-axis. So in all these three cases, time is taken on the x-axis. Okay, time is always taken on the x-axis. Remember this thing. Okay, so with that, today let us start discussing about the displacement time graph. Okay, so I think all of you have certain idea about graphs. Definitely you have done it in your mathematics class. Okay, so today when we are saying that we are plotting displacement time graph, what we actually do, we actually consider displacement on the y-axis and time on the x-axis. So in displacement time graph. Okay, so let us just discuss the various types of displacement time graph. Okay, what are the types? Now see, when you are considering the displacement time graph, actually what you are doing, you are plotting the, as I said, we are plotting the displacement on the y-axis and time on the x-axis. So displacement is generally denoted by the letter S. Okay, so it could be in meter, it could be in centimeter, and time denoted by letter T. It could be in second, minute, hour, anything. Okay, generally if I consider the SI units, the meter displacement is taken in meter, whereas this time is taken in second. Fine. Now, so this is the basic displacement time graph frame that we need to consider. Now, so what are the times that can actually arise while we are discussing about the displacement time graph? Now, first case we consider that when the body is at rest. So first case is that when body is at rest. So how will the displacement time graph look for a body which is at rest? When body is at rest, so what will be the nature of the graph, shape of the graph? So basically, what does it mean? That the body is not changing its position. That means it is having a constant displacement. Say if I consider a reference frame, and from that reference frame, because in that reference frame we consider a certain point to be our origin, say 0 0 coordinates. From that point we consider that a body is situated 2 meters away from that point, okay, and the body is at rest. So the body will be constantly at that position. The time may be changing, time is elapsing, but the body is not changing its position. So in that case, the displacement time graph will look something like this. The displacement time graph will look something like this. Say a linear, just a straight line, okay, just a straight line, fine. So this is the displacement time graph. So if I consider a displacement time graph of a body having which is at rest, so it will be just a straight line like this. See, you can actually understand from this graph that time is going on, time is moving on. Say 1 second, 2 seconds, 3 seconds, but the body is at a constant position. So its displacement is not changing. So this kind of graph represents a body which is at a rest. Now, if I say that the body is actually at the origin, then how it will be? Then we will be just getting a line on the origin itself, okay, like this. Getting a line like this, okay. With respect to time, the body is not changing, okay. So this is the displacement time graph. Fine, okay, okay. So this is the nature of a displacement time graph on the body at rest. Now, next thing that is we have already learned about uniform motion, non-uniform motion. Next thing that we are going to discuss for a displacement time graph is that when a body is in uniform motion. When a body is in uniform motion, okay. So let us consider the second case when the body is in uniform motion. Okay, fine. So just let me erase it off. Okay, just let me erase it off. Fine. So next, the second case that we are considering is that the body is in a uniform motion. Okay, uniform motion. Fine. Now, so what will be the nature of the graph? Body is at uniform motion. Uniform motion. Okay, uniform motion. So what will be the nature when the body is at uniform motion? Now see, when the body is in uniform motion, what happens? Actually, the body is covering, as we have discussed in the previous class, equal distances in equal time interval, isn't it? The body is covering equal intervals, equal distances, equal intervals of time. So it will be starting, if the body is starting from the origin, then it will be just a straight line passing through the origin. Okay, like this. If I consider equal some certain 2 seconds time spaces, you will be seeing that it is actually covering equal distance. So if I consider 2 second time frames, okay. So say for this is 0 second, then 2 second, 4 second, 6 second, then 8 second, then 10 second, like this. 2, 4, 6, 8. These are all in seconds. And if I consider the displacement in meter, okay, then see. If I consider the first 0 to 2 second, okay, and here if I say displacement is 2 meter, 4 meter, 6 meter, 8 meter, 10 meter, okay. So 2, 4, 6, 8, like this, okay. Now the body, when you are saying that it is traveling from 2 to 4 seconds, so say from 2 to 4 seconds, it is something like this, okay. 2 to 4 seconds, see, for the time frame 2 to 4 seconds, the body has moved from 2 meter to 4 meter. So what is the displacement? 2 meter. Again, if I consider from 4 second to 6 second, okay, so 4 second to 6 second, again, so again I will see that the body has moved from 4 meter to 6 meter. So again it is 2 meter. So like this, if I consider that the body is moving in uniform motion, then it will be actually traveling equal distance in equal time intervals, and this when represented in the graph will represent a straight line passing through the origin. Okay, so I think the concept is clear. Okay, so this is the case of a body having a uniform motion. Okay, now if I consider a non-uniform motion, okay, I think you have noticed the previous case, first case, this is the second case, and third case we will be considering a non-uniform motion. Okay, so for non-uniform motion, so when the body is just, I will add one word here, it's in at non-uniform motion. Okay, non-uniform motion. So when the body is at non-uniform motion, so what will be the nature of the graph? It will be something like this. It will not be a straight line, rather it will be a curve. So it's here we are representing time on the x-axis, okay, displacement on the y-axis, and the graph can be something like this, like a curved line. Okay, this can be the nature of the graph. As because it is not traveling equal distances in equal time intervals, so it will be like a curved line like this. Okay, so this is the actually displacement time graph for a non-uniform motion. Okay, now so this is 3 types. Okay, so if you have not noted it down, please pause the video and make a note of it. It will be useful for you to understand the various problems, the situations when they are described by the graphs. Okay, now from the displacement time graph, what you can calculate or what you can determine is the velocity. How can you determine the velocity? There is something called slope of a graph. Okay, slope of a graph. So when you are considering slope of a graph, actually the slope of this displacement time graph gives us the velocity of the body, okay, and slope is something which is determined for a graph as change in the y coordinate by change in the x coordinate. So slope is something, it is given as change in y coordinate or y axis, okay, by change in that x axis. Okay, change in x axis. So this is the configuration. Okay, so for velocity time displacement time graph, what you are plotting on the y axis is the displacement. So basically here we will be taking it as change in displacement. So change is represented by the triangle sign delta. Change in displacement by change in time. This is the slope of a displacement time graph. And as you know already that change in displacement and change in time is actually giving us the velocity. So from the slope of a displacement time graph, we can determine the velocity of a body. Okay, so we will be doing some numerical problems on this particular graphical representations. Then it will be easier for you to understand. Okay, so with that we come to the end of our lecture today. In the next class we will be discussing about this is the first displacement time graph. Then second it will be the velocity time graph, and third will be acceleration time graph. So in the next class we will be discussing about velocity time graph. Okay, so till then we will be seeing in the next video. If you have any query, please do mention in the comment box. We will be happy to solve your problem. Please study well. Take care. Goodbye.